Okay, so welcome everyone. This is lecture 5 for machine learning deployment. So let me get started with today's objectives. Okay, so everybody can hear me and see the screen, right? So if there's an issue, point out to me by chat or something, or by just using your voice. Okay, so where are we? We are in lecture 5. So last time we were looking at uh, Kubernetes and Google Kubernetes Engine as the managed version of Kubernetes, which is an orchestration container orchestration system. So, um, so today we're going to continue where we left off last time. Last time we had uploaded our image to Google Container Registry, and we're just going to instantiate a managed container. So last time we spent quite a bit of time on discussing what Kubernetes is and actually trying out Kubernetes on our own local machine using a single node cluster, which is Minikube. Okay, so let me discuss. Let me start with. Um, sorry. Yeah. So today's goal includes one point from last time, which is to be able to deploy a prediction model on GKE. We'll do that, and then the rest of today's goals are how to manage a workflow. It's not going to be a sklearn, but it's going to be how to manage a training workflow, and and then we'll look at an example of a a task scheduler. It's called cron. It's a really old battle tested program, so we'll see how to use that, and then we'll look at a workflow orchestration or workflow management system called Apache Airflow. Okay, and possibly next time we'll look at the managed version of Airflow on Google Cloud. Okay, I mean we can use Airflow with Kubernetes, for example. So that's the objective. So we want to know what we have already seen. We have seen how to train our models early on in the first lecture, and since then we have been just using pre models that we have already built, and they were on disk, right? So this time we will try to focus not so much on model serving, but model training itself and how to make that a little bit more production friendly. Okay, so but before that, let's deploy our model. We'll still do model serving in the first part. We'll deploy our model on Google Kubernetes Engine. Okay, so let's go back to lecture 4, orchestration using GKE. So, so there are two parts to orchestrate using orchestrate using GKE. First anyway, as a prerequisite, we need to have a Docker image built on a local machine, and then we have to upload it on Google Container Registry. We can actually source a image from not just Google Container Registry but from external sources as well, but they need to be publicly available. Okay, so let me start from the beginning of the section so that we will quickly recap what Google Container Registry and so on, and then we'll get to the GKE part. Okay, so GKE is basically GCP is a managed service by Google Cloud for running Kubernetes with and Kubernetes comes with all these infrastructural aspects like scaling and fault tolerance and so on. But the managed part would be to deal with the underlying machine. So if you are doing Kubernetes on your own set of 100 machines or 10 machines, then you have to worry a little bit about the underlying infrastructure because if machines fail, sure, Kubernetes can spin up your container on a different cluster, different machine, and so on. But you have to throw the machine out and get procure a new machine and so on. So those are things that you'll have to do in a hosted setup. But with GKE, you also get those things for those things as part of your service. Okay, and you can also deal with setting up your machines closer to your customers. For example, if you're a website that's being frequented by people from across multiple geographic areas, then you would prefer to keep your model serving containers closer to your customers. So you could have a model serving container in US and maybe one in Europe, one in Asia, and so on. Okay. So GKE's operation is very similar to ECS, and we spent quite a bit of time last time on working with AWS ECS. ECS is a proprietary technology, whereas GKE is, at least maybe large parts of it, are open source. So our goal would be to use GKE to deploy our recommendation system, the same model we've been using since lecture 1 or 2. So what we'll do is, and we did some of these things last time, so save our Docker image to the Google Container Registry, and then we'll use the image to spin up a Kubernetes cluster. And we'll create a very simple cluster, and the cluster is just gonna work with a single container. If you recall from last time, the cluster could have multiple nodes, and each node could have multiple pods, and pods could have multiple containers. So you don't need to know the all the network and all the underlying details of how pods talk to each other or how containers talk to each other and so on. Pods have a single IP, local IP inside the cluster, and they talk to each other. So there was a lot of details over there, but for us, we just have a single image and a single container that we want to spin up. Okay, so last time, so this is going to be a quick recap of container registry, how to get to that using, how to at least push your Docker image. So first you wanna, so these are the credentials that I got from, I think lecture 2, probably, when we were trying to use Google S3 storage, sorry, Google storage itself. We were trying to push something to Google storage through command line, as well as uh, maybe we're using serverless solutions. So, but anyway, so we created a service account, and so the service account credentials were downloaded at that point. You can always go to uh, you can create a service account by just going to IAM um, on Google Cloud. So there are a lot of accounts here, but you can create a new account and make it a, uh, I mean, roles and names for the roles and so on. Okay. But let's, I mean, we already have an account from before, so let's just use that. Um, so first thing to use is to use the credentials and pass it on to Docker. So Docker can actually push the image to container registry. So it should ideally, I mean, you need to use your, so you need to use your credentials, of course. This part of the string is the same. It's just reading the password from the, your cat operation, which just reads the file. And you're logging into the Google Container Registry. Okay, and you should see login succeeded. And then um, I was so we had created a local image called prediction underscore service. So you can give a tag to that. So give a new tag to the same image, and the tag is going to be has to depend on your project. So and in my case, the running project name through this course has been this authentic real some number. So you need to tag the existing image name with a new tag. Okay, and this tag is essentially the URL from URL for the repository. Okay, so this repository, and that's how you're going to access the image itself. Okay, so so we can actually quickly check this. So Docker images. Um, yeah, prediction service is here, and and that's the image we can pass on. Okay, let's go back. Um, So actually, I don't think I have a tag of this one, right? Okay, so let's actually run that tag. I mean, create that tag. Okay. So, oh, maybe we had it before. Okay, but so this is a tag. Okay. So next, we just need to push the image to GCR. Since we've already logged in and we've tagged it appropriately, we just have to issue Docker push and the name of the image. In this case, the name is what we just chose the last time. So once we do this, it will just push the image. So this is just the in progress aspect. And when you're done, you essentially will see statement like this. Okay, so that it's been pushed, and you'll get a size and some SHA-256 number. Okay, so at the end of the day, you have pushed the image, and we saw this last time. So let's go to container registry. Okay, so I think last time we might have pushed two. Okay, let's see. Prediction underscore service. Okay, so prediction underscore service is what we want to focus on. Let's ignore um, the other two repositories. So prediction service is what we pushed last time. Okay, so you can click on it and you'll see the URL. So essentially, this is the URL that you want to use. We will use when we create a container our Kubernetes cluster. Okay, so so that's what is being documented here. There's prediction service, and you can see the what is the um, name of the image and what it's tagged. Okay, so now let's actually spinning up Kubernetes cluster is relatively easy if you're only deploying a single container. So let's do that. So let's go to Kubernetes engine. Oh, well, it's taking some time. So actually, we don't need the clusters tab. Let's directly jump to the workloads tab on the left side. And let me, okay. And so in the workloads tab, there's actually a default choice that you'll see, which is basically deploy containerized application, which is exactly what we have. So let's click deploy. And here you'll see that you can edit the container. So first thing to do is to check the container, and you can see that you have a. So currently it's saying existing container image, and it's choosing some, I guess default container called Nginx latest. But instead of that, let's do a select operation, and you can see that there's so many containers that we can pick. We are actually going to pick the one prediction underscore service. Okay, so let's click on that, and we only have one with the tag latest. We could have different tags, okay, different uploads, the same repository with different tags. We could possibly pick a different one, but we only have one, so let's pick that, select that, and I don't think we have to change any configurations. So we pick the container, and okay, so let's hit continue, and we'll go to step 2. And in the configuration, we can change the application name to something that's interpretable. So maybe model server. So this is a name for the deployment. So configuration just means the deployment configuration that we spoke about last time. So there's a cluster, there's a deployment configuration. It basically once you so cluster is this bunch of machines. The configuration is what lets you map the things that you want to run, in particular the containers, to actual nodes in the cluster, and so we're gonna set that up. So application name, something on I'm just using model server, and then uh, we don't need labels and all that, so that's fine. So let's actually just go to, so here's there's some option called configure YAML. So YAML int markup language is a language for specifying the different properties for how your cluster should, how your deployment should look like. Sorry. So we're going to actually edit YAML. We have edited YAML last time when we were trying to not pull images from elsewhere, but to take the image locally. So we had added a string, if you recall. So this is useful, and we'll actually touch configuration of YAML again towards the end of today's um, towards the end of today's lecture. So okay, so cluster location zone, just choose a default unless you have a preference for a particular zone, and then hit deploy. And that's it. So for a single container deployment, it's actually very easy to spin up a Kubernetes cluster. So it's actually, I think it creates a 3-node Kubernetes cluster. So okay, in the meantime, yeah, let's go back here. Okay, I guess you'll see that the cluster will eventually get created, but in the meantime, just to recall how, what the moving components are. So we'll essentially, so we're creating a cluster, and we are also deploying the deployment configuration. So the configuration was set up in step 2, right? And so the cluster is going to be, I think, a 3-node cluster, and we deploy, essentially map the container or a pod to a node in the cluster. And so uh, uh, we are not using kubectl currently to work with this cluster, which we used for working with the Minikube last time. So we'll see how to work with kubectl in the second half of today's session. Okay, and we'll do that for not model serving, but for model training pipeline. So that's just a recap on how how you need to view the moving blocks. So these are these the things on the periphery are the nodes. They have a kubelet program, as well as a container management program like a Docker daemon or something running. And the kubelet is the one which interacts with the master or the controller, and kubectl is a way to interact with the master, and you can also interact with the master using their GUI. Okay, so looks like it's still getting created. Um, okay. Any questions at this point? Did anybody face an issue with working with Minikube? Wow, it's taking quite a bit of time. So let's. I guess we just have to wait. Okay. So it created the cluster. Now it's creating a deployment, which is that mapping from containers to or images to actually containers to the nodes. So let that set up. So what we're going to do next is so this deployment essentially starts running the container. So the image, although we pointed it to an image, so the image is actually instantiated by the Docker daemon into a container. So the container is now running and should be serving the model as in the predictions if it can be queried. Okay, but so it's very similar to ECS. We have to do something to expose that container to the external world. So it has finished setting up the container and deployment. It looks like there is an issue. Um, let's see. Does not have minimum availability. So why are the fonts pending? Okay, I guess interesting. Uh, well, I mean, so I just refreshed the interface and it says now that um, the uh, the parts, as I said, there are three parts here. I mean, so once it deployed on through the workload interface, we instantiated this. The cluster, you can it'll directly get you to this page. If not, you can go to cluster and click cluster, and it will show you the information. So here you can see that there are three managed pods, um, and what we care about is actually to expose this to external traffic. But let's go back to cluster. And okay, cluster size is 3, and you can see some specifications. So let's again go there, click on the cluster name. So it'll give you the details of a lot of things that were used in this cluster. So um, and you can see the instance type. Instance type is E2 medium. So and then you can look at nodes, and these are the 3 nodes, and it's all managed. And so we didn't have to explicitly instantiate, for example, 3 compute instances and create the cluster. So uh, now let's actually go to services. Not services. Um, so next we can next we can expose the service to the external world. So basically trigger the prediction request tradition request to the container. So for that, we'll have to uh, go and click on expose. I mean, it was right there. So now, which port do we expose? I think if I recall, the container's internal node is 80. So if you look at, I think Docker prediction service, the file, if you look at recommended by, if you look at the very end, it's quite a long file. So you can see port 80. Okay, so that's the port. And so let's go back here. Oops. So the port we want to map from is port 80. And so, but the target port, okay, so port 80 is going to be open, and the target port is going to be 80 for this container. And the protocol is just TCP. It's just standard default. And that's it. So just we've just mapped external request, which will come to port 80, to the internal port of the container, which is 80, and that's it. And so we can just expose it. because there was a choice of a load balancer. It was, I think, taking some time. So, I mean, so once it finishes, then we basically created a service, and then we can look at the external endpoint. This is the IP. So if you click on it, it should ideally work. Um, but let's see. This previous page is sending you to some page. Okay, so that's the page we wanted to get to, and that's the IP for our. I mean, that's the IP for our model prediction service. So as usual, we can use it to check um, user ID 200, and there's a bunch of recommendations as a JSON response. Okay, so and you guys can also check it, and you can certainly verify uh, what's the resource usage, right? So you can see what's the number of requests and so on. So you have network the monitoring of different metrics for this cluster as well. So so that's how you deploy. But so it's as you saw, it's actually more simpler than some of the other things that we did so far. Now we would like to tear down the cluster, tear down our deployment, and then the cluster itself. So to do that, we just do the reverse order. We first delete the service. The service detail is right here, so we can just delete it, and then you can delete the deployment, and then the cluster itself. So, and in this case, actually the deployment and the cluster creation was simultaneous, so we can actually delete it together. So. Um, so I'm gonna keep it on for a few more minutes. In the meantime, let's actually jump over to the yeah. I mean, so the challenge here is to see how if you can do the same creation of a cluster a little bit more manually. So you can go to cluster, create cluster, pick the number of nodes, and so on, and then deploy a container. And we'll probably try to do that today a little bit later. Okay. So any questions for that part? So in the meantime, let me quickly discuss some exercises for this section. So, Kubernetes is a very gigantic piece of software, and orchestration systems are really can get as complicated as, depends on the business use case and the organization. So here's the first exercise. First exercise is launch a Kubernetes cluster with a single pod container that loads and serves Jupyter notebooks. So you can, just like we were able to do Jupyter server, right? So we were able to run a Jupyter server on an EC2 machine and then access it via our own local browser. You can actually start Jupyter server inside the container and then do the appropriate port mapping. So 8888 to 80, for example, and we can access it via the web, via the browser. Okay, where the container itself, so where the Jupyter running environment itself is running inside a container inside a Kubernetes cluster. Okay, and the second exercise is to go through. There are a couple of more. So Kubernetes itself had a Minikube as a very simple single node cluster that you could start on your own machine as long as you have an appropriate hypervisor. So so K3s and Micro K8s also have introductory materials to get started on Kubernetes. So it's worthwhile going through that. You can change the image. So I think we used Miniconda latest as a starting image for our. If you look at the Docker file, actually we can just do that. If you look at the Docker file on the first line, it's the image from there, and that was useful because then we could easily deploy, so easily use PyTorch, okay, and easily install PyTorch. Otherwise, you may need a little bit more. You may have to install Python natively and then change and install PyTorch that way, which is still possible. In fact, later on today, we'll see an instance of a Docker file where we don't use Conda, but directly install Python. So it's good to change that. So you can change the starting image and deploy a cluster. The whole go through the whole exercise. That will be good. I think I somehow missed the chat window. Okay, it's over here. Yeah, and next is, for example, go through the documentation for Kubernetes and Docker, and uh, so in particular, you want to access the, let's say you're running a container and you want to get into the container. Let's say it's serving Jupyter, or for example, in our case, serving model predictions, right, at the endpoint. But what if you want to open a shell in that container? Remember, I mean, since a container, inside the container, there's a process running, but you essentially have a essentially have all the dependencies as in like a very thin Linux environment essentially. So you can start other programs. For example, Bash typically would present if your starting image is, let's say, Ubuntu or any of these like Python images. So can you start Bash and interactively work with it to debug things? Okay, so you can do that, and that's helpful. So try to access the shell of a running container. Okay, and finally, there's also some software by the folks from Canonical, from Ubuntu, who develop Ubuntu. So they have a program where you can start a mini cluster of virtual machines. It's actually nodes, virtual machines on your desktop. So it's actually useful. Where if you want to really spin up machines and then create a Kubernetes cluster on top of it, instead of using Minikube, for example. And on Google Kubernetes Engine itself, there is a tutorial which will let you deploy a guestbook app. Okay, it's not related to machine learning, but you can certainly go through the tutorial. Okay, so any questions about that part? We're gonna, although I said to TBD here. So any questions about that part? Okay, so as I said earlier, today's objective is to actually get away from model serving. So once you already have a model, you serve it. Right? So today we are going to switch gears a little bit and talk about how to train models in a way that's scalable and portable and amenable to a lot of like logging, monitoring, and so on. Okay? And for that, let's look at how to, let's revisit this idea of a workflow. We've already been implicitly doing a workflow before, but we'll revisit the workflow of essentially a training workflow, and then we'll look at how to automate the training as if so that it can run periodically. Okay. And then, so in that process, we want to look at what's the workflow, what's cron as a scheduler, and then what's Apache Airflow. Okay, it's just a tool for workflow management, and so one tool. So we're gonna be acquainted with that tool by the end of this session. If there are no questions, then let's actually move forward. So workflow. So um, in particular, when I say workflow, all I'm talking about is essentially a sequence of tasks to achieve something, right? So that's true in many, I guess, processes. But here we're talking about batch, workflows are also called pipelines. So essentially they involve touching a variety of data sources, generating features, maybe doing some post-processing, imputing, for example, may also involve exploration of the data, and then all the way to generating a trained model artifact. Okay, so that's what a workflow is, and that's what a batch pipeline is. A batch just means that all this is happening in an asynchronous way, and maybe periodically, and in one unit, as each part is a unit of task. Okay. And while we do these works or projects, we think of the process from start to end as blocks, as in blocks or tasks or jobs. Okay, they're all the same thing. And you think of them as a sequence of steps, essentially, as blocks that can be chained in a sequence. Chain just means that one follows the other, then the next one follows the previous one, and so on. And or more generally, you can think of this whole any process, or in particular data science analytics process, as a sequence of steps which can be represented as a DAG, or a directed acyclic graph. Right? Some tasks can be parallelized. Somebody can be working on um, uh, training, and somebody else can be working on some exploration or creating new features of the data. So some things in parallel, right? So it may not be exactly sequential as a chain. So those are some features of a data science uh, project. So some desirable properties when we want to do such projects, or when we don't want to do these, I guess the word they use is uh, model pipelines, because at the end of the day, we want to compute or train a model, is the ability to manage multiple pipelines. So maybe you're developing two different types of models. For example, in recommendation systems, there is this collaborative filtering based modeling, and there's also content-based modeling. Okay, content-based modeling is different from collaborative filtering based modeling, but they are two different pipelines potentially, because if you may involve two different types of models. You may want to run blocks and schedules. For example, the data. So let's say we've been talking about recommendation systems. So let's say we have data of users. Maybe we're collecting. Let's say we are Amazon. We're collecting data about how users respond to our recommendations today. Then at the end of the day, or at some periodic interval, we want to use that new data, attach it to the previous data, and rerun our training of our recommendation model, right? So which means that we want to, getting the data is a from some logging system is one block that has to be repeated every night, for example, and then retraining the model also needs to retraining of the model is the job, which also needs to happen right after this getting of new data, and so on. Okay, so we want a desirable property of any model pipeline is to be able to run these blocks on schedule. Okay, especially in production. You'll not see, I guess, you'll not probably see this in class projects, for example. And you also want to detect, in production or in business settings, you want to detect if a block has not finished or not done its job, and then somebody can manually intervene and fix that step. For example, maybe an ETL or a data pre-processing job is not has not gone according to some quality metric, some QA measures that you have, and so you may want to get a data engineer involved and recheck why some data is not getting correctly processed. Okay, so you want a model pipeline or anything to do with model pipelines to have this property that somebody can look into a block, stop it, manually intervene and fix it, and then the subsequent scheduled job still able to deal with it and work. Okay, so basically the goal is that we don't want too much of manual intervention while managing pipelines. So a pipeline could be quite complex. So a data engineer could be working on one small part of your whole data set, and so different team members could be looking at different aspects. So data engineers looking at ETL or some data related aspects, and data science folks looking at maybe models and metrics, and someone else be looking at visualizations and so on. So these are all tasks, and they are all related to each other, because one task may need input from the other task to finish, and so on. So but this coordination and the management of tasks is best done if it can be automated away, and workflow tools allow an organization, especially with multiple team members picking up many different parts of the whole pipeline, to manage this complexity. Okay, so workflow tools address these gaps, and what they allow you to do is to allow specification of the whole pipeline. Let's say a recommendation pipeline, or a churn prediction pipeline, for example, to see who's going to churn out from your offering product or service, and then try to get them back by doing marketing and so on. So there could be multiple pipelines. So they can be specified using DAGs and these directed acyclic graphs, and then and this workflow tool can ensure that the dependencies are met. So for example, if a task is scheduled to run every night and it's a training job, then hopefully the data is prepared and ready before the scheduled periodic job kicks in, right? Um, so and these tools can also sometimes automate in conjunction with the other tools, automate the allocation of resources like the compute storage and so on as well. So for example, a workflow tool can work with, let's say, Kubernetes to manage to help manage the modeling pipeline. Okay. There are many tools. Actually, a very short list is written here. MLflow is, we briefly touched upon MLflow as a way to have persistence of the model across slightly different environments. So for example, if you train it on Python 3.7, Python 3.7, and then you want to read the model back in Python 3.8, MLflow can potentially help there. But in general, all these are model management of our workflow management tools, not just for machine learning, but also in general. But we'll focus on today, and we'll focus on training. Okay, so model training management. So basically, these tools, there are many tools. So that means there is an explosive. There's probably interest in the industry for managing this complexity. So it's useful to know at least one of these tools. Okay, and so the short I guess summary is that these tools are important for production machine learning lifecycle management, especially with multiple stakeholders in your organization. So it's worthwhile to know this. So what is our goal today? We'll build a batch pipeline running in a container. So we've been working with containers for the past two sessions. So we'll again create a training pipeline with a focus on training rather than model serving this time. And then we'll use cron as a single machine periodic job scheduler. And then we'll also use Kubernetes as I guess, a cluster-based periodic job scheduler. Okay, and then we'll also try to explore a tool, the workflow management tool called Airflow. Any questions currently?
Which one of these tools are like mostly used right now? Is there any one who is winning the race?
I am not very knowledgeable in that direction. I think you'll see proponents of multiple of these systems. Um, Airflow has been there since 2015 or 16, and it's a project by Apache Foundation, so probably has a decent market share. But all of these, I think, for example, if you have heard of Databricks, which gives managed Spark clusters for you. I think they have integrated with MLflow, for example, I think decently tight integration there. So I'm not aware. I'm not sure which one is actually, but they all have same underlying idea. So and in particular, we're looking at Airflow because there's a reason is that you can actually specify the workflow or the pipeline in Python. So there's a pipeline itself, which is a task itself, which you can do it in any language. We're going to use Python for machine learning. But the description of the task dependencies themselves can also be described in Python. Okay, so that's why we're going to talk about Airflow here, but you can use anything else.
Cool. Yeah, thanks.
Okay, so let's actually, so this is going to be a little bit of a recap about just machine learning training. So, um, so, uh, so let's dive into it. So first, what are some common tasks, right? So the task is basically kind of pretty obvious to many of you here, is first extract data from somewhere. Maybe it's a CSV file on a disk, or it's a database SQL query that you need to run, or it could be somebody else has dumped data in certain formats, Parquet format or whatever, in some URL, internal URL or external URL that you need to fetch data from. So that's one task. Maybe there's some also data processing that you need to do once you fetch the raw data. That's another task. You need to train the model itself. So that will depend on the model class, whether it's implemented in a package, or you're writing it from scratch based on NumPy, or you're actually maybe using PyTorch. And then once the model is trained, then you want to predict on a test set. So that test set, hopefully, if you've done some pre-processing or scaling, rescaling for your training data, you apply the same thing to test data, and then apply the model to the test data to get predictions, and then you somehow have to also push the predictions to a database or to disk or somewhere, right? So these are all tasks. I mean, each one can also be further broken down into subtasks. Um, and so I guess this next bullet points are essentially saying what I just said. Um, um, for example, let's pick data reading. Data reading and writing requires access to external things, right, like a database or storage, especially with large data. And what you might have, or we might have worked on, when we work in individual capacity, we might have used local disk access, like pandas, read CSV or something like that. That may not be enough for a production setting. So you really need to know I/O, okay, so input output, how input output is managed in production settings. Okay. Um, I guess the thing that we will be interested in is that, okay, so there are these tasks, but these tasks may have to be repeatedly run. Okay, and in particular, we'll have to fetch the data again and again. We'll have to train the model again and again, and we'll have to make predictions again and again. And that's the nature of many deployed, such machine learning based services. So we'll classify our these model building pipelines into two types. Okay, first one is a persistent model pipeline, where what we do is we'll train a model, but the model training and retraining is decoupled from updating your predictions. So by which I mean that maybe I'll retrain the model every month, but maybe I have to generate the predictions every day. Okay. So that's, it's essentially saying that, okay, you train the model once, dump the model onto disk, which is what we've been doing for the past the previous sessions. We have a single model. We didn't retrain it, and we didn't retrain it because we did not have any fresh data, because the toy data that we're using, it's fixed, it's stale, and it's fixed, right? But even when we get new predictions to make, we'll use the same data. So it's as if the model training loop has nothing to do with the how frequently you need to regenerate predictions, or let's say you want to generate predictions and dump it to disk, then there is no relation between retraining the model and updating predictions. Okay. But the second type is the transient model pipeline, where you don't really think of the model as an output object. Okay, it's some intermediate object. What you care about is data and predictions. Okay, so basically the model update is tightly coupled with prediction. So think of it this way. So every night you get fresh data. So you have data about your users. Let's say we're always talking about recommendation systems anyway. So let's say we have new data about user interactions with different movies on your app. You have new data. With that new data, you retrain and create a new model from scratch, but you don't really care about that model. Using that model, you predict what new movies you can recommend, and only that recommendations are output, maybe returned to disk or to a database, and the model that you created is dumped. Okay, it's just deleted. In the sense of it's not important. Okay, so that's a transient model pipeline. So here prediction is tightly coupled. Updating predictions is tightly coupled with model updates. Okay. So both have their pros and cons. For example, if your data distribution is very changing quite a bit, essentially you're in a non-stationary environment, in the sense that there's very high seasonality, and there is really not much correlation of except for the most recent past and so on. You will have to do this. Okay, you'll have to anyway update the model very frequently. So let's look at a transient pipeline. So so first important consideration is because we are going to build the model again and again, let's say in some frequent interval, we'll need the compute resources. For example, if it's a PyTorch based model, then we'll have to, and if it's a decently sophisticated model, then you'll need a GPU resource, for example. So whether to have a transient pipeline or a persistent model pipeline also comes down to what you think is the nature of your data, and what you think are your costs are, right? If you want to keep the cost low, maybe you want to keep a persistent model pipeline, for example. So what we're going to do is the following, right? We get the training data, like in this transient pipeline, for example, train a model, use it for predictions, and save. And in particular, what we're going to do is we will try out BigQuery, Google BigQuery, again a managed I guess database of some sort, to dump our model predictions. Okay, And what we're going to do is also, so historically we have trained a PyTorch-based matrix factorization model. We have also trained a matrix factorization-based model using a package called surpriselib, which has the same API like scikit-learn API. So you have a model.fit and model.predict function calls. Similarly, today we're going to use a slightly different package. It's called lightfm. Okay, uh, so lightfm is actually useful for those recommendation problems where you don't have an explicit rating. Okay, and surprise lib, for example, or matrix factorization based techniques make sense when you have an explicit rating from the user. Okay, so for example, movie lens happens to have ratings. It's actually users who saw movies and then rated the movie between whatever 1 to 5, uh, uh, and so there is explicit ratings there. Okay. So we're going to look at a particular example. So let me go to that LightFM's um, page. So what? Okay, let's actually see. So what I'm going to do is also demonstrate a couple of other tools. So first thing is Colab. So how many of you have used Google Colab? Oh, it's not used Google Colab, let's say. Okay, what I'm going to do is I open that GitHub link. So there's a notebook, and you can actually see the notebook right here. But you can also use that URL, copy the URL, go to collab.research.google. It's a service that you can use with your Google account, and you can just go to GitHub. Maybe not quick start. Let's just go all the way to LightFM. Oops. Okay, and there's something on quick start. So let's go to quick start. So here you actually get a working Jupyter-like environment where you can run each of the cells. Okay, so I don't know if this will work. Okay, run anyway. I mean, I haven't tried it, but I just wanted to show this to you. Uh, yeah, we need to install LightFM. So, okay, that's fine. So I wanted to just show you that you can quickly run a notebook on Google Colab. So, but for today's training, to give an example of these blocks, right? Getting data, training the model, dumping the model to disk, and so on. We'll rely on this example, but actually, yeah, um, yeah, but so if so this is one way. So first is you can just read the notebook from here and copy it into your local machine. If you're running a Jupyter instance, like how I am running here, I think. Yeah, this is local machine. Yeah, okay. So I am running it on my local machine. I think it's slightly modified. Uh, so Okay, let me come back here. So what I'm trying to show is that, so we're going to use this package. Okay, what is it going to do? It's going to help me build a recommendation model. Okay, so same as before, same as the first lecture or the previous sessions that we were looking at. It's a different package. That's good. So I was just trying to show you the 2 or 3 ways of how to read that notebook. Okay. First is directly look at GitHub. Second thing is you use Colab. Third thing is you can directly you can clone the repository. So you can use a utility called Git to clone the repository, and once you clone it, you can go into you can, as long as the Jupyter session, so Jupyter server can access that repository, you can go to the repository and open the notebook. Okay? Let me just see the notebook right here, and then we can talk about the modification. So it's a very, so let's come back to our original task, right? So batches of blocks of tasks. So the first task, fetch movie lens, right? So if you actually go to so fetch movie lens is a function call, right? But if you actually go to the package library and go to LightFM, datasets, and movie lens, okay? So if you look at how it fetches movie lens data, there's so many operations going on. So a lot of functions here. Many of them are, so this is the fetch movie lens function. And it has a lot of processing going on, right? So you can see that this fetching data itself is it could be messy operation. And this is for a very well curated data set. So you can imagine how difficult it is for a generic data set, right? So, but that's been abstracted away. Let's go back to our notebook. So this is the first task, right? Next, we're just seeing what's the representation. It turns out to be a sparse matrix representation for this notebook. That's okay. Next, so there's no post-processing being done because fetch movie lens is already doing fetching the data from a URL and you know changing it so that it's amenable for subsequent processing. And then you have a call to the model class, with which you can define the model object and then fit the model, right? So here is where you're fitting the model. So you're giving some parameters like number of epochs to train and so on. And so this is the training part, right? So and then you can print a few things here, but in reality you will want to dump these metrics as well as the model to disk somewhere. Okay, so maybe on S3 or Google Storage or something. And then here's a function which is like just sample recommendations, sample recommendations. So here you can pass a user ID and you'll get back a recommendation. And this is what we've been doing, but with other libraries, with PyTorch and with SurpluseLib before, right? So for example, here, if you give the user number 3, they are printing out what are the 3 movies that they've already seen and what is the set of recommended movies that we can recommend. Okay, so that's the original notebook. So what we're going to do is slightly modify it, and I have, yeah, I think I mentioned all this. Okay, there was one more point I did not mention. Let me talk about the slight modification in a minute, but one more point I wanted to mention about a collab is that you can actually go to runtime, and I think some of you already know this. You can go to runtime, change runtime type, and you can change from Python 2 to 3, which makes sense. And you can also use GPU machines, okay? And you can also use the Pro version, which will have a longer, better service level availability. Sorry, service level agreements. So that's, I just want to cover that before coming back to our um, so we'll start with the quick start notebook. Okay, so it has already a data fetching part, a model training part, and it doesn't have a model dumping or predictions for test users part, but we'll add that. So I think there was a link to the Jupyter notebook. Maybe I'm missing it here. Oh no, it is there. So okay, so before that, one more trick before I talk about our model is that you can actually, so okay, so let's say I cloned the repository and I went to the quick start directory. You can actually run the notebook without opening it in the browser and clicking run all or anything. So you can actually use Jupyter nbconvert command line argument with some additional arguments to run the whole notebook. So you don't have to actually open it and do a run all. Okay. But anyway, let's come back to our notebook. So that's, oh no, that's not the one. Okay. Yeah. So the notebook's name, I've changed it to recommend underscore light FM. So let's look at it just to see what changes I've done. So for those of you who are seeing this for the first time, just remember that cell 1 is doing some data fetching. Cell 3 and 4 are doing the model fitting. And then cell 7 onwards, actually cell 8 onwards, I'm going to talk about now, is the using the model for making predictions and dumping the predictions somewhere else. Okay, so let's do that. So till here, you saw it in the previous, in the original notebook. So next, I created a function called all recommendations, and I'm just creating, top 10 recommended movies for every user. Okay, so in this, I'm assuming that all the user symmetry data are the ones who are going to stay in my test, as in are the ones for whom I'm going to make recommendations. So I'm not taking into account new users here. There are ways to do that, but that's not the goal today. Um, so what I'm doing is, given the model, given the, in particular, I want to get inside this data object, I want to get the test usernames, which actually is the same as training usernames. So I'm just using the training usernames. And in fact, the user IDs are just serialized from 0 to maximum number of users in this example. So it's easy. So I'm just producing a bunch of predictions, as in scores, what they would, I think they would rate. Based on that, I'm sorting and getting the top 10 items, or top 10 items, and then I'm just creating a data frame which has for each user what the 10 recommendations are. Okay, and I'm just returning the data frame. So if you look at the data frame, you'll see that so this is a user ID. There's an index as well, but there's a user ID in the data frame, and uh, there's a column called rec, which actually has a string of these movies. Okay, this was in hindsight a bad choice. I could have done it with 10 different columns, with each column having the first recommended movie, second recommended movie, and all that. And finally, you have prediction times. So with that, what we'll try to do is, so we have the data frame, okay, in this notebook. Now, with that, what we can do is also, once we have this data frame, we can actually save it somewhere, right, on a database. And we're gonna use the example of Google BigQuery to do this. So here's the small snippet of code to do that. So we're actually relying on having our I think I missed something here. So it's Google credential file, I think, to be on the directory. Remember, there was a model-user.json. It's also needed for the Docker push to Google Container Registry. So we um, need that. Actually, I think we may not need it because we have explicitly mentioned the location of this. So um, we'll rely on a package called pandas underscore Google BigQuery, but you don't have to use this. There's actually an alternative package by Google itself to push the data frame. So we're going to use this and create a. So what are we trying to do here? We have the recommendations, and which is a data frame currently for every user. What's the new recommendations that we can give? Now we want to just dump it into a location where it can be used by some other service. In particular, for example, a prediction serving service, which can read from that database and make the predictions. So make show the predictions, for example. Like the app itself can read from BigQuery and show the predictions, right? The movie recommendation app. So what I'm doing here is just creating a database with a table called predicted movies. In my project, the project I've been used, the project which is the Google Cloud project, and then I'm using the credential file that I created 2-3 sessions ago, and then I'm just sending the data frame. Okay, so let's actually see if it works. If it doesn't, then we'll fix it. Um, so LightFM is not installed. Okay, that is. Okay, let's go here. Uh, I'm not sure. Okay, here I don't think I should activate it. Let me just see if my Jupyter notebook is running in the Conda environment. Um, yeah. Okay, let me say pitch Python. Okay, so this is fine. And what should I use? Okay, let's just go to LightFM's web page and install it. So we can install it using Paper Conda. So I was just trying to figure out which is a better option. So let's use this. Okay, let's use this. So what's the difference between those two? I told you in the earlier class. Conda is a environment manager, which also serves as a package manager, doubles up as a package manager, whereas pip is just a package manager. And they have different ways of dealing with packages. So Conda, I think, precompiles for specific targets like Mac uh, and so on. So whereas pip may sometimes have to compile locally. Uh, so okay, we installed it. Let's go back to the. Okay, let's restart the kernel. Okay, so actually first time we run it, it's actually downloading. So the downloading is actually important because it's downloading the data from a remote resource. So so that's how you do it. So although fetch movie lens is really you know obfuscating or not showing what are the complexity of this function call, it's actually downloading the data from a remote resource, right? And then processing it. So you would have to do something similar. So you may have to get the data from another database. So that whole operation is being condensed here. Um, okay, and then you can check the sizes. The sizes is about 1,000 users and 1,500 movies. Okay, so let's import Light FM. And um, okay, so wow, the model.fit was quick. So I could actually import that and print accuracy. So it's quite, test and train are not even close to each other in terms of precision at K. It's a precision at K is a measure for how well you're recommending, the things that you're showing as the top things that the user will engage with. Is the person actually engaging with them or not? Okay. Um, so okay. So sample recommendations, we don't need that function. So let's run the um, uh, this function all recommendations, and then we can see the head. So actually, we can actually also see how many recommendations are there. It should be the same as the number of users. So now, okay, let's. So we have the data frame, right? Right. So these are all the. So if you look at df, let's look at rec, and I'm just gonna pick the first entry. So sorry. Um, so you see this is actually a long. Okay, it's actually a string. Okay. Oh, it's actually a array. Oh, okay, good. So okay, so it's an array. But what happens is when I dump this to BigQuery, then I think I lose that property of an array and it becomes a string. So this is one of the exercises I think I mentioned in the exercises page is to change this format to something which is more amenable. So next, let's look at. So that's it. So that's training part, and then training part is very quick, and then this function call is just generating the predictions. Okay, and it will not be this simple because you actually have to fetch the users for which you want to make predictions from another service. Okay, so maybe new users signed up and or things like that. Okay, so let's actually run this. Okay, no module name. Okay, we did not install this. So let's go back. Um, is this good? Okay, they do have a way to install from Conda. So let's actually do that. Oh, okay, this is a different, I could have used it, but okay, this is fine. Let's use this. So any questions in the meantime of what we're trying to do? We are just trying to do the last step, which is to push the, wow, so many things getting updated. Push the data frame with the predictions to a remote location. Okay, just to show how you could do it. And we'll actually rely on this script, this um, training script again and again through this session. Okay, I think let me just double check this Google Auth Okay, I don't see the version number. Maybe if needed, I'll have to downgrade the version. Let me go back. Okay, I need to restart the kernel, which means I have to re-execute everything. Um, let's run all and see what happens. Okay, no file, no such file. Okay, well, ls. Okay, I need to do something. So let me just copy it from the. I mean, I can reroute it to that location, but let me just copy it anyway. Um, oh, it's not there. Oh, model. Okay, uh, let's run this. Now, if it's about no attribute credentials file. Okay, I think I'll have to change something, which is something I mentioned even um, in the notes. I think we'll have to downgrade the Google Core Cloud Core to a lower version. Okay, let me just do that sometimes. So this is the type of issues it will face if you have package. Um, you know, either you can keep updating packages and deal with breaking changes, or you freeze the package installation versions, right? So you can give a pip install file name, sorry, package name, and then you can actually specify, the way we specified just now, right? So what did we do? We said conda install. Okay, I think we can revisit that. So we did conda install Google Cloud Core double equal to 1.3.0. So that's freezing the version that we want. Okay. Um, let's try once more. I shouldn't have done this, but okay. I think this time it seems to be working. Okay, I shouldn't have done this copying again, but um, so it didn't error out. So actually, okay, so that's fine. Now let's go back to, so we did something, right? We pushed our data frame to Google BigQuery. So let's actually just quickly have a look at what it is. Um, this is still running. Okay, actually maybe it's a good time to uh, stop it. Okay, delete horizontal pod autoscaler. I did not know that. Okay, so anyway, it's terminating. Let's maybe open another console. And this time, let's go to bigquery. Let's go here. So so you can see this is the default interface of BigQuery. It's very useful to it's essentially it gives you a query editor very similar to, because it's probably essentially the same as SQL, and you can query different databases and tables. So in particular for my project, I'm focused on the bottom right, so bottom left. You can see my project name here, Authentic Rig. I can open that. This is a database movie recommendation service, and then within that there's a predicted movies table. Okay, so you can look at some information about it. So that's look at some information about it. For example, what's the schema? So the schema is just UID rec column and then the prediction time. And if you see some information about when this was created, uh, so it was created. So it was created just now at 7:47. Okay, um, and you can look at the preview of it, which is this is the user ID, and unfortunately that array becomes a string here. And then when was it? When did we make the prediction? So for example, if I rerun it, you will see that it's gonna. Let's close this anyway. And where did it go? So for example, if I rerun it, uh, I think from 7:46 it should change to, or 7:47 it should change to 7:50. Yeah, it changed 7:50. So basically, you can. Yeah, I just rewrote the table, which is probably not a good practice, but um, so that's how you get your at least output into an external service, and that's what we saw just now. Okay. So what we'll do now is we did many of the steps, and we didn't export Google application credentials only because I think we explicitly gave the location for the credentials to be in the same directory in the notebook. But if needed, you just have to do this. Okay, to your the service accounts credential file. So, and if you want to double check whether your credentials make sense, then you just on the command line, we've already installed a Google Cloud command line utility. So you can type Google Cloud auth list to see what's the um, account and what's the project. For example, config list will tell you which project is the default project that you're looking at. Okay, um, so this is fine. We have done most of this. Yeah, and as I said, actually the same thing, and I'm not going to spend much time here. You can actually run instead of running run all, opening the Jupyter server and running run all. You don't have to run a Jupyter server. If you have a notebook, let's say your team member gives you a notebook and they want you to keep running it every, daily, you can just run this command, right? Jupyter nb convert is a nice utility for you to convert the Jupyter notebook to, for example, a HTML file and so on, but also to just execute the whole script. Okay, and so if I do this, then again the predictions will get updated, but I'm not gonna do that now. Um, yeah, and what I'll do instead is, now that's just on BigQuery and we've already seen how to dump data to BigQuery, let's actually also look at how to get the data back from BigQuery. So it's a very short script. So I don't think we even need pandas here, but okay. So I think the dependency is already directly ensured. So import pandas, import this BigQuery, I guess, class, um, and then create a client. And then for this, I think we'll need the, what is that service? Google credential files to be in the appropriate location. And then you can just query with a SQL, and here I'm querying um, every column, every all the data. But I can do the usual thing like limit 5, or just select, for example, just a UID, for example. So I don't know if it will run. Okay, it'll run because it's able to find the default. No, it will not run. So yeah, so I have to run this. Um, uh, run this. Okay, there are a lot of things. So users. Let's see if it works. Uh, hello. Okay. No, I think I'll have to restart. So I need to actually, I might have to do this on the command line. So let's actually do that. Um, okay, that will require me to restart the machine, restart the Jupyter server. But okay, let me actually do that, and then we can take a break. So let me shut down these. Right. Okay, let me restart the Jupyter notebook. Okay. Um, I don't know, this should by default out. Okay, so it is there. Um, so now let's query from BigQuery. Default credential error. Okay, oh, I use mode. Okay, I think I'll fix this in the meantime in the break. So let's take a break and come back at 8:06. And if you have questions, please put it on the chat. Okay, so I hope everybody's back. So I just restarted the Jupyter um, notebook server. Let me just go back to this query. Uh, I don't need this, but I can rerun this and see that it is actually model user. So it's 8:07. So we can see that it's probably running, and we should be able to read this list of recommendations. So we're only reading UID. Okay, so maybe I will have to rerun the query. Okay, I think the next query is a different query anyway, so it's fine. JSON decode error, value line 1, column 1. Okay, so this I am not sure, so let me actually not. I think it's probably an issue with to data frame, and to change it to and look at the head. Okay, I seem to be getting some error, which is not good. So let me execute it for last time, and maybe I'll try to fix it offline. Um, it looks like there is an issue with the not the query structure here, but probably um, how we this query maybe getting timed out or something. So the two data frame will not probably work. So this is again a chaining of tasks, and if the previous task fails, then the subsequent task will also throw an error. Um, yeah, it looks like I think it's not generating it's not able to access. Um, okay, so I think I'll fix it offline. Um, let's actually move a little bit forward. So this was actually not very critical. I mean, reading it from Python is not important. You can certainly query it directly on, for example, here, right? You can write the same query here, and you'll see because you have the, you have the table, so you can query. Okay. But we do want to have automated tools like uh, bigquery, the Google package. So sorry, you would like to have programmatic interface for querying prediction for users. So let's move forward. Yeah, there was a remark about format. I think that's something one of you or all of you should try as an exercise to get rid of, because once you read it back, you'll see that it's a string, that particular field. So in this exercise so far, in creating a in creating a transient model pipeline where the model itself was not important, the input was data and the output was essentially predictions. And we would, every time we want to get the predictions, new predictions, fresh data, we can re-trigger this whole pipeline and get fresh predictions. Now, although we wrote it in a single script, in reality, it's not a single script. All these actions are their own separate tasks. So, for example, you could have fetch data, train, predict, and shipping predictions to a database service like BigQuery. So it makes sense to have that at least 4 blocks. And in this way, if a block fails, then you can retry its execution. Um, and if the previous block fails, the succeeding blocks um, can be retried after some time. And if a block fails, you can manually, if there is some manual something intervention that can help, then a team member can be alerted, and then they can um, uh, fix it. Okay, so we'll attack this part about scheduling, so that we can redo these jobs again and again, and there'll be some rudimentary aspects about emailing to the concerned owner, or in this case the person who started the job, if the job fails or succeeds or so on. Okay, so one such tool is cron, and we'll play with that first and then move on to Airflow. Okay? And before getting to using cron with our the whole pipeline, we'll actually introduce again containers, not because it's critical to demonstrate the functionality of cron, but to show how so that we can put it on a container, and then cron can call a docker run, so we docker run image name, and so that the whole thing instantiated, reads the data, trains the model, dumps the predictions to BigQuery. Okay, so that's what we're going to try to do. So let's move to the next section. So creating a Docker image for the transient pipeline is quite straightforward. So let's actually convert the notebook to a convert the notebook to a Python file. Okay, so and you can just run this command to do that. So let's go here. So actually already have that file. So if I open that file, you can see that it's actually just the same file. You can see all the additional in and out kind of denotes that this is actually a conversion from a notebook file. So we'll keep this the same, um, and I will not redo that operation of converting it into a Python file. But once we do that, yeah. So once we do that, you can just execute it, right? So we can just execute the same script. So let's actually do that. It's a new terminal. So this was the script, and this query failed. So let's close that. Let's shut down it. This, and you can see this is terminal running. Okay, so let's go back here. Okay, that's your file. Um, so we'll run it here. So it's 8:15. So we should see a timestamp on Google's page, on the BigQuery page for 8:15. Okay. I don't know. Let's go back here actually. So you can preview, and you can, in the preview you can probably see the timestamp when it was pushed or generated and pushed. But I see some issues with Google today. Let's look at the preview. Okay, let's just look at the details. Wow, everything is resolving today. Okay, so it looks like there's an issue with maybe BigQuery. So not this one. Um, I'm wondering if I should change the location and retry. Test. So let me run the. So this is just to double check that it's not an error with writing a file to BigQuery, writing the predictions to BigQuery. Still, we can check this from command line as well. I think the updates are not happening. Okay, I think this is not very critical for our next step. So let's actually go with the Dockerization um, uh, of our script. So what we did so far is go through the transient training pipeline in a notebook. And right now, 2 minutes ago, we changed that to going from a notebook to a Python script. Okay, so that was just Jupyter NB convert would get us the Python script. Then we can actually run Python recommend.py, and we actually did that here. And there's some warnings which should be fixed, but in the meantime, it terminated without an error. So the writing part is, I think, writing the BigQuery. It seems like there is some failure somewhere. Oh no, it eventually wrote. So this is what we did. So we just created a test database, and there should be a table, but I think um, Google Cloud is slow today for some reason. But we'll move forward. So we did that. We ran it, and then what we're going to do now is to Dockerize it, right? So to do that, we're going to do a little bit differently than before. So um, we're going to create a small bash script called, we're just calling it run transient pipeline.shell, where it's going to do two things. One is export, the Google application credentials environment variable to be equal to slash model hyphen user.json slash, because what will happen is when you're creating the image, we're going to put all the files in the root directory, as in this in the file system root. So that's where the JSON file will also be. And then what we'll do is we'll actually run, when the container starts, we'll actually call this shell script, and then the shell script is going to execute the export and then call recommend lightfm.py. Okay, so that's what we're going to do, and that file is already present with me, and you can also download it, I believe. So run transient. Okay, so this is just a couple of lines. It's just Python recommend that. Okay, so with that, let's go back. So we have this transient file. So now we're going to create a Docker um, image, and for that we'll need a Docker file. So the Docker file is as follows. So this is a slightly different Docker file from the previous recommendation, models that we've been deploying. So the models we'll be deploying, we needed, for example, to install Flask. We'll not be installing Flask here. And one of the models, for example, PyTorch, we were basing it off Continuum's image, and the Continuum's Miniconda image, and then we were installing using Conda, PyTorch, and so on. Okay, so this time we changed the repository, so starting image to a different image, and this time we'll just install Python. These are the lines to install Python 3, and then we're gonna install what to write to the BigQuery, which is Panda's Google BigQuery, package. You can actually use a different package. We'll need the lightfm model, because model is an intermediate artifact that we'll create, and we'll also need NumPy to get those sparse matrix representations for our data set. And then we'll also install Google Cloud Core. We'll downgrade to 1.3.0 because of some compatibility issue with Panda's GBQ. So with that, so those are the installations. Then what are we going to do? What are the files we need is the from the notebook we converted our notebook to a Python file. That's the file we'll copy into the container. So copy to create that image. We'll also copy the credentials file. This may not be the best security practice, so here I'm just using it for convenience. And then we'll copy the shell script, and then we'll change the permissions for the shell script to be executable. So that's what chmod means. Will let us change the permissions to +x. +x means make it inexecutable, and then we'll. So this is the command that will be run when the container starts, when the container based on this image starts. Okay, so we'll build that. I don't think recommend hyphen underscore pipeline is in the Docker images list. So it's not none prediction service, weather service, all that stuff. So we can actually run it, but we should be in the right folder. So there's a lot of files in this particular folder, but what we care about is this Docker file, the Python file, and the run transient pipeline, and also the model user JSON. So the remaining ones, just ignore it. So let's build it. So Docker image build with the tag recommend pipeline, recommend underscore pipeline. Okay, and dot just means the current directory has a Docker file. Oh, so it's going to build the image. Oh, that was very quick. Or it could be because I executed, I might have executed this installs before. Okay. Generally, it's not that quick. If you have to download and install these, it will take some time. Okay, so the Docker images, we have the recommend pipeline. So to ensure that, to check that it's working, we can run, actually, I wanted to double check. So this is test, right? So this is on this one. So whereas the other, so this is a notebook, and let's actually close the notebook. Over here, shut down. The file that we used to make the image was actually this py file, and the py file's destination is actually model recommendation service. Okay, so so now that we have the image, so we just have to run docker run image name. Okay, so that will run the container. So the command pipeline. Okay, so it ran. So I mean, so uh, yeah, so our script ran, and you can see the intermediate, printing out the sizes of our train and test matrices. So if we look at Docker PS, the container ran, it finished the script, and so it exited. So if you do ps minus a, you will see so many other containers, but this is the container, so that ran. It exited about a few seconds ago, and so its status is basically it's exited. Okay, that's the status. If it's the output is not very clear, but it's exited. So because thing ran, let's go back to bigquery if it's working, and see it's 820, so maybe 8. Uh, okay, so it was updated around 826 or 827. So you can see the timestamp inside as well. Okay, this timestamp is actually saying one. So it's showing tomorrow because I think it's in UTC time. So you have to do -5 hours or something. Okay, so it works. So we ran the Docker image. I mean, we created a container from Docker image and ran it locally, and it works. So uh, So any questions up to this part before we? So we just containerized our training script. So we're not really interested in predictions at this point, but it's essentially doing predictions because the training script is running, fetching the data, running, and then dumping the predictions to a database. From the database, some other service can read from the database and make the predictions in real time as a web server. So if there are no questions, let's move forward. Um, so we have the Docker image. It's running well. So now let's talk about cron. So cron is a really I think the initial version was from 1975. So that's a lot of years, 40 years. Um, 45 years, right? So it's a command line service or basically command line program or a daemon. Daemon just means it's a server for time-based scheduling of any program. And in particular, in our case, it's going to be the scheduling of our Docker run command. Okay, so we'll run Docker run basically creates a container from an image. So we're going to do a Docker run from our image in a periodic manner. And when we do that, it's going to fetch the data. So it's actually fetching data. It's just that the fetch data is always the same. And then it's going to dump the predictions to BigQuery. Okay. So cron is a useful tool to automate system maintenance as well as do some system administration. Its name originates from the Greek word chronos. Um, and the benefit of cron is it's a very useful tool for a lot of system administrators. And so for single machine scheduled tasks, like if you want to scrape at periodic intervals something from this website, let's say weather website, then you can do that with cron, for example. And because of its easy to use ways and relatively limited functionality compared to other tools, it's probably difficult to go wrong. Okay. Key limitations for cron are it's tied to a single machine. So imagine although we've been talking about managed services and container orchestration and so on, so there we don't have the granularity of working at an instance level. Okay, so the nodes themselves, which node our container runs itself is not uh, predetermined, right? So that that type of extension, you need additional tooling on top of cron, and you'll see Airflow as a way to do that actually today, um, maybe early next session. Um, so so those are some of the cons. So you may need some additional code for to work with it in a larger model pipeline maintenance perspective from that perspective. So um, but it's a great time to time tested utility. So it's good to learn it. So cron tab is the command line utility to interact and interact. So command line utility to set up a cron job. Okay, so a cron job or a cron task. Okay, and you can set it up as a user or as a root. The task for us is we can, although we'll show how to set it up for the Docker run command itself. We can first try it with just a Python script as well. So um, if you look at the nodes, yeah. Yeah, and so there are two types of, I guess, cron task specification descriptions. One is where you specify one are, I guess, system jobs, and the other one is user jobs. So we'll mostly be focused on user jobs, at least for today. We can make a task specification, and you'll see that it's just a single line description of run this job at certain times. Okay, using the command cron tab. So we're not so although this cron tab minus e just means edit, is gonna essentially make a single line entry in some file in the file system. For example, mostly cron is mostly available in many Linux files, Linux as well as Mac operating systems, for example. For Windows users, try to use a VM or the EC2 instance or something like that to work with this. Um, so So you don't want to, so you don't generally edit the file directly. Okay, you want to edit the file using cron tab minus e command. So and the task schedules are essentially in terms of a single line description of when to repeat the task. Okay, so for example, in particular, the general description is that you need to have 5 numbers. Okay, 5 numbers or 5 symbols followed by the command you want to run, and then subsequent with spaces the arguments that the command needs, if any. Okay. These additional, so in addition to the numbers, these locations can also have 4 symbols: the star, the minus, the slash, and the comma. Okay, and I'll briefly describe it pretty soon. Um, Yeah. So basically, what are these 5 numbers, right? So first number is essentially saying at what frequency. So all these numbers are trying to say at what frequency at certain resolution of time. Okay. So the first number is saying the first number will say, it can be between 0 to 59. It'll just say every dot number minute. Okay. So if the number is 1, then every first minute of an hour, you should run this command. Okay, so every 59th minute of this hour, of every hour, you should run this command. If every other, okay, if every other of these numbers is a star. Okay, so let me explain with some examples right below. So let me first tell you the specification for each number location. So first number is talking about minutes. Second number is for the hour of the day. The third number is for the month. Okay, so it's a day of the month from first day to 31st day maximum. And then the fourth number is for the month, and the fifth is for the day of the week. So is it Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or whatever. Okay, so let's say we want to run a task, then sorry, so if you want to run it as a system task, you want to also provide your username. But when you edit a cron tab, so when you make a task specification, something like this, and I'll show you some demonstrations pretty soon, the task is run according to the user privileges that define this task. Okay, so if so my user account currently is IDS user, so I'm going to edit the cron tab with say run a command, which is let's say docker run that transient training pipeline, then that command will be run according to my user privileges. Okay, so if I have privilege to run Docker, then I can run it. So, sorry. So let's come back here. So here are some examples. So first example. So let's say we want to run a command or like the script, like run a transient pipeline.shell.sh, right? We want to run it every 12 minutes past 2 p.m. How are we going to specify it? The first entry is going to be 12 to represent the 12th minute. Okay. The second entry is going to be 2 p.m. So 2 p.m. is of the 14th hour. And then the next 3 has to be stars so that it runs every 12th minute of every 2 p.m. that will be there. And so every day there's going to be 2 p.m. So every day. So these 3 stars mean for all days, for all months, for all days, all days and the days of the week as well. Okay. So that's the first example. Any questions about this? So let's look at a second example. So if you want to run a task, let's say on a specific day, let's say 5th day of the month and 7th day of the month, maybe useful for tax-related products or some reminder type of commands or email reminders that need to be sent on the 5th day and the 7th day of the month. Then you can say, okay, sometime, let's say the 12th minute of 2 p.m. and then 5th and the 7th day of the month. Okay, and it has to be repeated every month, and this is just this is the star just means not applicable basically. So the third example is, let's say you want to run every 2 hours, right? So how do you specify that? You can do so 12th minute, and then to run so every 2 hours, you'll say 0 to 23, which is all the hours, /2. So the /2 means go from 0 to 23 with the jumps of 2. So 0 plus 2, 2 plus 2, whatever, 4, 4 plus 2, and so on. Okay. So and then these others are star. Okay. So stars just means there's no constraint, all values for that field, like the third, fourth, and fifth field. Okay. So that's how you would schedule. So all I'm saying is you just have to manipulate these 5 numbers and specify the program that you want to run. Okay. And uh, finally, one more thing is that by default, cron will try to email the outcome of running the command. And it makes sense for servers which can actually send emails to, as long as you set up the outgoing, so as long as you set up the email configuration on the system so that it can actually send mails, right? Then you can, it ties in nicely with the cron scheduling, so it will tell you the outcome of the running the command, success, failure, and things like that. Okay, but if you just want to redirect the output to a file, then you use this type of you know uh, bracket. Here I'm redirecting it to a place where it basically is dumping. It's not going to be written anywhere. So that's the redirection happening here. But this is not very important. All I'm saying is you can uh, set up, like if you have a command and you want to log it somewhere, then you can actually redirect it to something like, okay, my function, my command.log somewhere, let's say in a appropriate location, and it will dump the outputs there. Okay. So with that, let's actually open cron tab. Um, Cron tab minus E. Okay, there's actually no entry here, so let's do star. Okay, these are 5 stars. Okay, I actually didn't think about this, so let's, oh, actually, yeah, echo, let's say my name, and then I'm going to redirect it and actually double 2 of these square brackets, not square brackets, sorry, 2 of these symbols imply append operation, okay, and we're going to append it to uh, slash desktop slash architecture of file slash some log. Okay, I'm just arbitrarily creating something. So what does this mean? So since I put all stars, it just means that run every minute. Okay, run every minute, run every hour, run every day of the month, run every month, basically every day, weekday, weekend, and so on. And echo teja is just an example command, but you can say you can do dot slash sorry, you can do run transient pipeline dot sh, for example, and let's write and quit. You will the Mac may say you don't should this be allowed. So we have edited it. Okay, so now okay, it may also send us mails, but try to send us mails, but actually we can try. Let's slash maybe not yet. Okay. Um, okay. So let's see. Um, okay. So okay, we waited some time just so that since it runs every minute, not at a low resolution. So let's see what the situation is. Okay, there is a teja.log. So you can just see. I should have echoed time. So it's run once, but if you give let it continue to run. Okay. So far it's just one entry. Okay. So that's how you would set up a cron job. So let's actually come back and focus here. So um, Um, okay, so on Mac it doesn't show this prompt, but on on a Linux machine it'll tell you what these parts mean. So minutes, hours, and day, and so on. So Um, and the second thing is, if you are confused about whether you're specifying the scheduling correctly or not, whether it will run on, let's say, the 5th day and the 13th day at these times, you can always use one of these URLs. For example, this one, like for example, if I do the same and then do echo, I mean, it's not show the, so if I do test, um, okay, it's not fast. 2, 3. Okay, I guess the test doesn't work. So let's do first minute. I don't know if it works, but okay, I guess it's not correct. So let's actually go back and see what the issue with the command is. Um, star, star. Set every minute. So this is correct, but I guess uh, this did not let me, or maybe, okay, don't think I should do. Maybe username is missing. Okay, I'm not sure what's the error here, but so you can check. Okay, so there are tools that let you double check that you're scheduling correctly. And if you go back to, so if I do less, it's been a few minutes, actually 4 minutes. So that's how you would, uh, this is one example, very simple example. And actually let me, so if you see, so this will list all the cron jobs that you can run, and I can edit it. Sorry, I can remove it. Removes all the jobs there. So after -R, if you do -E, you'll not see the job. Okay. So that's a very simple demo for cron. Now let's actually come back to, so we can do this, right? So we can say, if we're running from local machine and we wanted to dump trainings, so not just local machine on, let's say, an EC2 server, and we have a image which can fetch data from somewhere, process it, learn a model, make predictions, and push it to somewhere else. You can actually run a cron job like this. So run every 0th minute. So run every hour, basically, this Docker run command. Okay. So we're not going to do it right now because we're not going to wait for an hour. We could do star, 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 star and check it on BigQuery, but we've already checked it many times. So what we'll do next is to try to move to the cloud and run cron. So I think we have less minutes. So we'll do this, and then we'll get to Apache Airflow early next lecture. Okay, and we'll probably check how it will help in better management of workflows. So let's look at how to work with cron on the cloud. Um, so cron is actually is also provided as a managed option by many cloud providers, and so in particular, Kubernetes actually allows us to do that directly by specifying a schedule in the YAML file. So recall we had created a YAML file when we did Kubernetes locally using Minikube, where we changed the Docker as the image pull policy to be local or never or something like that. So instead of that, so in the same type of YAML file, we'll also specify uh, how to run the image. Okay, how frequently to run the image. Okay, so let's come down. Um, so we have the image. So actually, we already have the. Okay, so again, so to run to set up the cluster, again, we'll have to go to our uh, so BigQuery is fine. Let's go back to our container registry. So I have uploaded the Docker image previously. So it's basically what the image that we had. Um, so this image recommend underscore pipeline, I've already uploaded it before. So you can see underscore pipeline hyphen pipeline, they are the same thing. So we have the image uploaded. Um, Next, what we're going to do is actually, since we already have the image, we're just going to repeat the same thing that what we did at the beginning of this session. So we're going to create a Kubernetes cluster. And to do so, let's actually go to um, Kubernetes page. But before that, let's just copy this. Um, I'm just temporarily copying it. Let's go to Kubernetes. So this time we're not going to do the way we did at the beginning of the session. So we haven't deleted this. Okay, so let's delete this. In the meantime, so let's create a cluster. So let's click create cluster. Okay, so what we're going to do is instead of, so the default, so we can always choose this, but we'll choose a slightly affordable cluster, which just means that the underlying machines are a little bit cheaper. So let's click my first cluster. So what will happen is, it's a little bit smaller and achievement small and stuff in E2 medium. Okay, so there's a little bit less compute resources being used. So we're just going to use my first cluster as the choice. Okay, we'll just create now. And wait for the cluster creation. In the meantime, I think that one was getting deleted, the model server cluster. Okay, so next what we'll do is let the cluster get created. In the meantime, we want to we want to deploy. So we want to deploy a specification which says run this Docker image as a container from this image periodically, right? So we'll actually use kubectl, and how we're going to use kubectl is that we'll try to we'll try to use the Cloud Shell. Okay, so let's try to do that. I have no idea why Google is quite slow today. What is a sheep? Okay, I think I have limited uh, resources. Okay, I think since I'm running out of time, maybe I'll do this also early next in the early part of next session. So, okay, let me just resolve back and summarize what I've been trying to do and what we've done so far. Um, so today we looked at Google Kubernetes engine, right, which is what we're trying to repeat now. How to deploy a single container on Google Kubernetes engine, a model serving container, and we got the URL and we could check that it works. So that actually is a PyTorch model. So it's kind of quite a heavy model because it's essentially a neural network um, that's running to do the inference for predicting recommendations. Next, we looked at looked at the data science workflows in general, and then we started talking about persistent and transient model training pipelines. Spent a lot more time on transient model pipelines, and then we saw an example using LightFM package to make the recommendations and dump it to Google BigQuery. Then we talked about how to use cron to schedule jobs in general. We didn't schedule it to schedule the Docker image, but we built a Docker image for our model training pipeline so that we could use that image in a Kubernetes container and schedule it to run periodically. Okay, and that's the step where I think I'm getting delayed with Google Cloud Platform. So, oops, oh, deleted immediately. Okay. Um, So that's where I was getting a little bit delayed. So I'm gonna do that early next week. So so where we are is to these are the two steps remaining for today's session. So which we'll do early next week. Is the first thing is to we have the image already on Google Container Registry. So we will create a Kubernetes cluster, read from that registry our Docker image, but we'll change the YAML file, the corresponding deployment configuration YAML file, so that there's also a schedule attached to it, which says, okay, run this container every 1 hour. Recall that this container is different from the previous containers that we've been using. The previous containers, we were starting a web server, Flask web server. So it was always running, okay, till you kill the container or till you stop the container, it would run. Here, the container stops the moment it finishes its task, right? If the Python script says, okay, I got the data, I trained the model, I dumped the predictions to BigQuery, I'm done. So then the container is, exits already. Okay. So that's why we need to restart the container again and again periodically to get fresh data, get the predictions and push it to external resource like BigQuery. So that's one step. And next step is to get acquainted with Airflow is a model management tool. I didn't get a chance to spend much time on it today. So early next week, early next time, we're gonna look at that. Any questions about it? Any questions so far?
And is this all from the book? The book mentions this.
Which most likely, I think, yeah. So it's not exactly from the book, right? So we are looking at recommendation systems. I think the book looks at something else mostly. But I think, yeah, the book, we are following the book. So if you look at the where is this course logistics schedule? Yeah, lecture. Yeah, it's a reference to chapter 5. So if you're interested, look at chapter 5. But it may have a slightly different narrative, but it's mostly follows what we're discussing here, or we follow mostly what's discussed in the chapter.
Okay, cool.
Yeah.
Thank you.
Uh, if there are no questions, then that's it for today. Thank you so much.